Casting is a manufacturing process in which a liquid material is usually poured into a mold, which contains a hollow cavity of the desired shape, and then allowed to solidify. The solidified part is also known as a casting, which is ejected or broken out of the mold to complete the process. Casting materials are usually metals or various cold-setting materials that cure after mixing two or more components together. Examples are epoxy, concrete, plaster and clay. Casting is most often used for making complex shapes that would be otherwise difficult or uneconomical to make by other methods. Casting is a 6,000-year-old process. The oldest surviving casting is a copper frog from 3200 BC. Types: metal casting is one of the most common casting processes. Metal patterns are more expensive but are more dimensionally stable and durable. Metallic patterns are used where repetitive production of castings is required in large quantities. Plaster, concrete, or plastic resin. Plaster and other chemical curing materials such as concrete and plastic resin may be cast using single-use waste molds as noted above. Multiple-use piece molds, or molds made of small rigid pieces or of flexible materials such as latex, rubber. When casting plaster or concrete, the material surface is flat and lacks transparency. Often topical treatments are applied to the surface. For example, painting and etching can be used in a way that give the appearance of metal or stone. Alternatively, the material is altered in its initial casting process and may contain colored sand so as to give an appearance of stone. By casting concrete, rather than plaster, it is possible to create sculptures, fountains, or seating for outdoor use. A simulation of high-quality marble may be made using certain chemically set plastic resins with powdered stone added for coloration, often with multiple colors worked in. The latter is a common means of making washstand tops and shower stalls, with the skilled working of multiple colors resulting in simulated staining patterns, as is often found in natural marble or travertine. Casting process simulation. Casting process simulation uses numerical methods to calculate cast component quality considering mold filling, solidification and cooling, and provides a quantitative prediction of casting mechanical properties, thermal stresses and distortion. Simulation accurately describes a cast component's quality upfront before production starts. The casting rigging can be designed with respect to the required component properties. This has benefits beyond a reduction in pre-production sampling, as the precise layout of the complete casting system also leads to energy, material, and tooling savings. The software supports the user in component design, the determination of melting practice and casting methoding through to pattern and mold making, heat treatment, and finishing. This saves costs along the entire casting manufacturing route. Casting process simulation was initially developed at universities starting from the early 70s, mainly in Europe and in the US, and is regarded as the most important innovation in casting technology over the last 50 years. Since the late 80s, commercial programs are available which make it possible for foundries to gain new insight into what is happening inside the mold or die during the casting process. Bibliography: Campbell, John, Casting, Butterworth Heinemann, ISBN 0-7506-47906.